So, good morning. So we are in the process of discussing on sensing. So today we are going to discuss on sensing types. So what are the different sensing types? Okay. So in the last class till here you might have done, isn't it? All these things is completed, no, in the previous class. I think we have done with sensorial deviation. Okay. Then we have to today go ahead with sensing types. So let us see what is the sensing types. So listen here. So some of the sensors are prone to external factors or external influences. So you know that most of the sensors will be designed with which device? Semiconductor devices. You know that, right? So most of the devices will be designed with semiconductor devices. So what is that when you are going with semiconductor devices? See, when you are subjected to external factors like humidity or rain, or you can say that temperature variations, high temperature, all those things, sometimes the semiconductor it is made up of semiconductor devices. So what will happen? The property may change. Okay, the property of that devices might slightly change. So there are certain conditions through which you have to go through it. Okay, so sensors may be prone to external influences which may be directly linked or it may indirectly get affected to the sensor. Okay. What else you can see? Sensitivity of the sensors may lead to the deviations of the output values. So, for example, if you know that the sensors are made of semiconductor devices, semiconductor things. So when the temperature or any other parameter is too high, so what will happen? It will change the property. So indirectly, what it will affect? Yeah, it will affect the sensing ability, and finally the output value it will affect. Is it not? So it will affect the output value of the sensing. So what you can see here is sensitivity of a sensor may lead to deviations, and so this is because of the output external factors, and which will directly or indirectly affect what. For example, you are deployed a sensor at some point. Okay, there is a huge variation in temperature or whatever parameters it is changing, and it is affecting your sensor. Okay, so what will happen? Where it will reflect for you? Where it will reflect in the output? It will reflect. Is it not? You have a sensor. For example, this is your sensor. Okay, this is made up of semiconductor. This will have so the external factors also it will be affecting on the sensor. So if it will be continuously monitoring and giving you the output values, it is a continuous process. So when there is a change in external factors and all those things, what will happen? Sometimes the property of this device itself may change. So once the property of the device may change, whatever it is sensing, and whatever the final output you are going to get cannot be the required output what you need. Is it not? So all those problems are there. So those things has to be taken care. For example, most of the sensors and semiconductor based are influenced by temperature of their environment. So temperature is a major factor. For example, if you are deploying some sensors in some remote places where the temperature is too high. Okay, so starting around it may be trying to withstand the temperature and it may be trying to give you the values. Gradually, you can see that the temperature is highly influencing the sensor and it is changing the property. May not be the same pattern what it was giving before, it is going to give it in the next few days later. So that's what it may affect on these things. For example, now let us take your laptop only. Okay, you take the laptop itself, you are working in a very cool climate, or you can say that you are working in an AC environment kind of thing. So your performance of the laptop will not be a problem. But suddenly you take it to a very high temperature, where it is 50, 55 degrees centigrade, and you are working for some time. You may see that suddenly the heat dissipation will be more. Your laptop may get shut down fast, or all those problems may take place. So, how it is taking place? Because of the properties of the devices, it may not able to withstand those parameters which is there in the external field. Okay. So that's the thing. So sensors are influenced by the external factors as well. So we have to consider all these parameters when you are designing a sensor. So you can just make a note of those things. I think today's class is a note of today itself. So what are the different types of sensors? We will see. We don't get confused with the writing answer. What I am using in this message handling for you. Write the right answer for the right person. So that is only because you may get confused what answer where to write. So we'll continue. So let us see further. So what is the sensing types? So sensing types, you can say that scalar, then it is multimedia sensing, hybrid sensing, and virtual sensing. So let us see the first one, scalar sensing. So it is classified as scalar, multimedia, hybrid, and virtual. So what is a scalar sensing? What do you mean by scalar sensing? Correct. Scalar, scalar sensing, you can say like thermometer. So like somewhere fire happened. Okay, at one particular room, there is a immediately fire takes place. So how you will come to know that? You know that when there is a fire, there will be a rise in temperature. So whatever sensor is connected to measure the temperature parameter of that place will definitely show a spike in the increase in temperature. So you can make sure that there is no reason for a spike, isn't it? So definitely they should have gone. They could have happened a fire over there. So that is how you can predict. So it will give an alarm system. If you connect a alarm system method, it will give you an alarm system stating that there might have happened a fire. Okay. So those things and all you can measure using the scalar sensing. So you can see that sensors used to measure these scalar quantities are referred to as scalar sensing. For example, the environment where suddenly fire occurs, so that can be measured with the help of a temperature sensor. Okay, so measuring the change in what will happen. So you might have seen digital thermometer. For measuring fever and so how it is changing? So it will what it will take? It will measure the changes in the amplitude and measure the values with respect to the time. So it will see that what is the variation of amplitude, and this amplitude means this corresponds to this much temperature. This amplitude corresponds to this much temperature. So like that, there is a correlation between. So when this reaches that voltage amplitude, then it will make sure that this is the temperature to be displayed. I think you can meditate later. So, so the measuring when you are talking with respect to temperature, the temperature variations will lead to the means that the temperature variations it will lead because of the change in amplitude. So when there is a change in amplitude, you can say that for example some voltage amplitude it will be mapped to a certain temperature. So when there is a variation in the amplitude, you can see the variation in the temperature as well. Okay. So let us see the next one. So you can see that if you are really when you are really manufacturing your project, some of the projects may be based on the temperature sensing also. So you can see that the variations in the temperature and all those things can be observed when you are doing a real time project. Okay. So after your internal ceremony, you are going to submit, right? So that time you can see that. So different, make sure that your all the projects are different. Don't go with the same concept. So next one is quantities such as temperature, then current, atmospheric pressure, rainfall, light, humidity. All these parameters comes under the scalar process of measuring, and other consider the scalar values and directional to that. Then measuring the changes. What will happen? When you are, for example, how you have talked about the temperature. The same way you can see that atmospheric pressure when there is a rainfall. How to measure the rainfall and all? No. You might have you can see that when there is a rainfall, it will say that yeah rain is occurring. Okay, so you can have the projects of that kind of see when one drop falls on the sensor, it will say that yeah there is a rain in process. Okay, so all those things can be or when the water increases the level, like certain level, it will water if somebody is doing water level sensor and all you are using and you are seeing the project right. So those things and all can be used there. Okay. So measuring the change in changing the values by passing time provides the information regarding what are the parameters you are going to measure. For example, at 9 o'clock you have 25 degrees centigrade. 9:10 you will be having 25.02. So like that, each time it will be varying, and based on the time you can see that there will be variance in the temperature as well. All these parameters can be measured. So what is the next one? Multimedia. So what is multimedia sensing? This one. Multimedia, what it is? Multimedia sensing?
Two different things at the same time. Water temperature activity.
Yeah.
So
Multimedia is not there. Your photos, videos, and all those images. So in scalar sensors and multimedia sensors are used to capturing the changes in amplitude of the properties like concerned to space, okay, space as well as time. So quantities such as image, multimedia, it will come quantities such as image, direction, flow, speed, acceleration, sound, force, mass, all these things you know, right? So the parameters such as speed. So how you can make sure that the speed is increasing, speed is reducing. You might have seen in everywhere you can measure the speed of vehicle and all those things, right? So then mass of that energy, then momentum have both directions as well as the magnitude. So which is having both direction and magnitude, you call it as a multimedia sensing. So these all things comes under that, like acceleration, sound, force, mass, energy, momentum, all this which has directions as well as magnitude. Okay. So if you are using the sensors which can measure the direction as well as magnitude, we classify that as multimedia sensing. And how it is done with the help of videos, images, and all those things you can find out there. Second unit is including today's class. So, is that clear? Multimedia sensing? So, we will see further. So, if you have an environment, so where these changes has to be measured, so you can use a camera sensor, which can be used in order to measure the changes with respect to both the magnitude and. You have seen anywhere like this?
motion sensor.
Yeah. Yes. So you can see those applications also. So you can see the surveillance. You see, no, that how they will observe people moving and around, whether the people were there, person were not there, how they will observe with the help of multimedia sensor. See now for example, before when 2020 and all, you can see that drones flying to monitor that the crowd is too much or not. So those are all comes under multimedia sensing. So you can make sure that the crowd is there or not there. At this point it is low, this point it is less. So camera sensors can be used in order to let's find out the environmental means like surveillance and all those things applications can be which can come under this multimedia application. Okay. Multimedia sensing. Then what is the next one? Hybrid. Hybrid means what? You know that hybrid means what? Combination. Okay. So there is a need to measure certain vectors as well as scalar properties of an environment at the same time. So if you sometimes need scalar and vector properties to be measured at the same time, you use the hybrid sensing. Example, in the agriculture field, measure the soil condition at regular intervals of time. See, if you see the agriculture application, there are many applications. So sometimes you may need to measure the soil parameters at frequent intervals of time. Okay. So there and all you need all the things. You may use the specific sensors which can give you the parameters whatever you need. Sometimes it may be the what are things you measure for the soil? Water content, pH levels, then minerals, what are the minerals present in the soil, then what else you will measure? Anyone is having agriculture land where these sensors are required? Okay, what else? So, the measurement of some of the example is agriculture field where you can measure the soil conditions at regular intervals of time. Just don't stick on to the same points in the exam. So let us see the next one. So you can see here, let us take that example and let us see how it is. You can see you have plants being connected to a built soil and you are connecting a sensor here, for example. Soil moisture of the sensors such as soil moisture and soil temperature. You have moisture sensor, you have temperature sensor. If you deploy that temperature sensor inside the soil as well as moisture sensor. Moisture sensor and temperature sensor, if you deploy inside the soil, you can make sure that the continuous monitoring of moisture as well as temperature will be given. Okay. So it will be deployed to understand the estimate the water content as well as the moisture available in the soil and determines whether the plant is getting enough water or not. So, for example, you need some plants doesn't need more water, but some plants need continuous watering. Okay. So, whether sufficient water content is available or not. So, this is very important for us to understand. And they may also boost the water availability and may affect the health of the plant. So, if it is, see, if water is less also it is a problem, water is more also it will be a problem. So you need to maintain a certain level. So the sensor will help you to understand whether the water content is sufficient for the plant whichever you have planted or it is more or less. So if it is more, you should stop the water content to be flowing to your field, and if it is less, you should make sure that you give the sufficient water. Okay. So it will be giving a clear indication of whatever crop you have planted. So you can set all those things. So whether the water content for this crop is this much. So what is to be done for that? Okay. Are you noting down anything? So we'll see the next one. What is the next last one? Virtual. Virtual means what? What is virtual? Ah. For example, I have three fields here. One, two, three. Agriculture field. Okay. So I am connecting a sensor here. I am not connecting any sensors here. I am connecting a sensor there also. I am having parameters measured from this side. I am having parameters measured from this side because I have two sensors. Right? Without measuring the parameters, I can predict that what will be the soil moisture content, what will be the soil pH, everything in this space. But only condition is what? It should be close by. It should not be far. Okay? Like this is connected somewhere, that is connected. If it is all close by, I have a one field I have connected a sensor, another field also I have connected a sensor, but this portion I have not connected any sensor. But still, with the help of these parameters of A and C, I can predict what is the parameter of B. Okay. So let us see that. So this portion also additional inclusion of camera, which can, if you are including the camera, and what are the parameters you can do? You can take the pictures of the leaves and their fruits, whatever it comes up. Okay, and you can do the technique of machine learning, and you can do the comparative analysis. You can say that is there any thing affecting the plants, like any diseases are there, whether it is getting affecting, whether it is affecting the plants or not. All those things can be evaluated. Okay. So you can do a comparative analysis of many varieties of plants. You can say that this, if you do the analysis, you can say that whether it is giving you a good crop or not. All those things can be evaluated. Okay. So determines the actual condition of the plant. All the measurements of the farmer A, because you have connected a sensor. But the neighbor B field will have the same parameters as that of the field A. So without having a physical sensor being connected, you can make sure that from one of the farmer A, but it should be nearby field. Okay. You can, without measuring any of the parameters of B, the farmer can make sure that it will be almost the same parameters. Okay. So you can say that it is highly likely that the measurements from the sensor will be available and provide almost the same things for the neighbors B also. Okay. So this is immediately surrounded by, only condition is the farm should be close by. It should be surrounded to farmer A. So let us see that if the data from A field, so if you are collecting whatever information from field A is digitized using IoT infrastructure, and then advise him to like appropriate watering, fertilizer, and pesticides, all those things you are going to use there. The advice can also be used by farmer B. Okay, that is the same thing. For example, if any crop finds that there is a problem, same advice can be given to farmer B without being any sensor connected at farmer B land. We have not connected any sensors to the land B. We have connected only sensors to the land A. Keeping the parameters of land A, we are giving advice even to land B also. So A sensor are being used to actually measure the parameters which can be physically used for being advising for the crop which is connected in land B as well. Okay, is that clear for you? Means we are virtually giving the advice for the farmer B with the supporting evidence of farmer A. But it should be a neighboring fields. Okay. So next we can see that this is how it is. S1 and S3, and you are saying that this is the process of virtual sensing. So is that clear for you, all the four? What are the four things we have studied? Scalar and virtual. It is clear for you? So that's what, if you have a farmer A and B, you are connecting the sensors to the farmer A land, and you can give even with the same parameters, you can give an advice to farmer B as well. Okay. So for that you are not see, like farmer A and B can put together, they can invest for one land, and they can make sure that it is being shared for the other land as well. So it's a thing. So that's all about this. So we'll stop it here. Okay, this till here it will be there for your internals. Okay, and further topics if I am taking, that will not be there for your internals for first IA. It will be there for your second IA. So till here you can prepare for your first IA. Thank you.